Good afternoon, everyone. I sent you the link yesterday, and I didn't say too much about sharing the exam and some concerns students had about the grading in Moodle. I sent your concerns to the administrators, and they will look at it. It looks like Moodle made mistakes. I'm not sure why. So we'll sort that out, and don't worry about that too much. As I mentioned, there'll be the opportunity to rewrite the midterm on Thursday at 6 o'clock till 9 o'clock. And also at the same time, I will post a set of retests for the quizzes, the in-class quizzes, which are now going to be distance quizzes. Okay, so that's what's going to happen on Thursday at 6. However, until then, and all week from 5 to 6, I'll be making these videos just for an hour, and you can review them in your own time, or you can join us at any time. I will keep sending the link with the coverage or the material we'll be covering, so you can prepare. So what you should have printed with you today are the notes for Unit 4. And Unit 4, very excited about Unit 4 because this is going to be probability theory. And I like to start on page 7. So if you can scroll to page 7 or turn to page 7, we start there. And then there actually are several videos for many of the other pages. And I will ask you to look at those before we meet again tomorrow. Okay, so that's how today's going to go. You have videos starting, I'm just confirming, on page 10. But I'll talk about page 7 today and some other points, and then you can watch what's online, and we'll meet again tomorrow. Okay, so let me scroll. I'll move to page 7. So I like page 7 a lot. It's a summary of what you need to take away from this unit. Okay, I pulled it together with 4, these are called Venn diagrams. With these 4 Venn diagrams, I can introduce and contrast different concepts in probability. So it doesn't say Venn anywhere on here, but these are Venn diagrams. Venn. All right. And they might look familiar to you. You may have seen them before. This might be a review for some people, but most people need this explanation. And even if people have studied statistics before, they appreciate the explanation this way. All right. So what I prefer is that you attempt to answer a set of questions for me, and then we'll get back together, or you can start the video to see what the answers are. All right. So if you're just watching this on your own, you can pause the video, and after I present the questions. So using these diagrams, what I want to solve for, and I'll explain the elements of the drawings each time. So I'm here just putting the questions down. All right, so I want to look at these events. So an event is something that happens, all right? And I'm going to define an event, something that happens, like like it's raining, like it's sunny outside. Okay, you talk about temperature. An event like we're observing people driving by, and we observe if they have the right license plate. If it's an even day to travel, they have an even license plate, or if they have an odd license plate. These are events, okay? So there's something I'm looking for or something that's about to happen. So in this case, in the first instance, I have two events, A and B. A and B, and they complete S, the sample space. So this is called S. This is the sample space. So this rectangle, this shape, is a shape. It includes all the possible outcomes. Okay, but the way I define it is critical. So in this case, I simplify it and I say either A happens or B happens. Okay, so those are the only two possible things that are going to happen. I've limited my interest to whether A happens or B happens in the space S of all possible outcomes. S is the sample space. So what I want to do for each of these different drawings, because look, as you go through them, in here A and B complete the space. Here A and B are included in the space. They don't overlap, so they don't share any outcome. And there's something else out here that we're going to give a name. In the lower two look familiar, similar. They have A and B overlapping. And then you have this outside space here. And then I have it repeated here for some reason. Okay, so I'm going to go through this. So just looking at this, I'm going to go through this. I'm going to present the case for, I'm going to give you some numbers. Now, you don't have to do this with numbers. You can do this, stare at this theoretically to understand the properties of these different relationships between events. But it's easier. I find that just if I put numbers on it, students grasp it better. So we're going to say, for each case, I want to compute this, this, and this. Okay, so for each case, 1, 2, 3, and 4, I want to compute the probability, that's what the P means, okay, the probability that event A happens and B happens. So we think of and, the word and, as just that. Both the events happen simultaneously or sequentially, but they happen together, okay? A or B is the understanding that A happens or B happens. This is actually in words, we can define probability of A and B is defined as the intersection. Let me do that again. of two events. And A or B is known as the union. And sometimes you might see notation like union, rather than or, a U is used, and rather than the word and, an upside down U is used for intersection. So you might see those symbols in my notes or in reading on this topic. All right. So you'll understand that better with the drawings as well. There's a third calculation I want you to make, and that is not A or B. Okay, so this is familiar to you, and a lot of what we're going to do is intuitive, actually. There's a lot of intuition here, and I want to spend some time teasing apart your understanding so we can separate what you understand properly, and I want to clarify what's misunderstood, because there are some common errors in understanding probability. So to actually calculate anything, I got to give you some numbers, right? So let's say I'm going to say that I'm going to check something. Give me a second. I just want to check something. I'm just looking to make sure I use the right numbers for my example. Okay, so the chance that A occurs, or the probability of A, and we'll understand probability and notions of probability better when I review this. I'm starting at the end, okay? This is like a summary of what you're going to learn. And I start there because, like as I said, some of this you have an intuition for already. So let's just clear up and solidify what you understand and that you're good at, and then focus on what you have trouble with, okay? And I'm going to start with probability of A. Let's say the chance that A occurs is equal to 30%. And we're going to talk about how I figured that out, or where I got that from. Can you see that? Probability of A is 30%. And the probability, if the probability of A is 30%, in case A, that's here, I could figure out from that the probability of B, and I could answer all three of these questions very easily. So I only need that piece of information, and that's the case because A and B are complementary events. We say they're complementary. They complete the space. So since A's chance is 30% of occurring, has 30% chance of occurring, then because they complete the space and the total space is 100%, it must be the case that the chance of B happening is 100% minus 30%, which is 70% in this case. All right? So that's just an example. So this is, even though that's A and B, this is probability of A. I'm going to just rewrite that as, so P of A is 0.3, then P of B is 0.7. And the reason is that they must sum to 1, or 100%. in the space. So this should be familiar. This should feel familiar to you. This is like the normal distribution, where we understand the area under the normal distribution is 1 or 100%. And because of that, I can use my z-table or the left side or the percentiles. From there, I can understand the probability of events, the probability of seeing observations above a certain threshold. Okay, so the table, as we explained, the table just gives me the area to the left. Oops, that's interesting. Okay, so now let's get to my questions. The questions are, what is the probability of A and B? What's the probability of A or B? And what's the probability of not A or B? So the chance of A and B occurring simultaneously when events are complementary, it's either A or B. So they cannot occur at the same time. So with complementary events, this will always be 0. And how am I going to write that? Okay, let's do it in blue. So this is going to equal 0 for complementary events. What about A or B? For complementary events, the chance that A happens or B happens. So what's the chance, in other words, of being in A or of being in B? Well, they complete the space. It's 100% chance that either A or B happen, because only one of A or B happens. So this actually ends up being 1. Notice it doesn't matter what A was, what its chance of occurring was, or the chance of B occurring. If events are complementary, it's always going to be the case that the probability of A and B is 0, and the probability of A or B is 1. Finally, the question about not A or B. What's the chance of not seeing event A or event B? That's what not means. It's the concept of not is actually complementary. It's everything but these two. Is there anything but these two? No, there's nothing. There's just A or B. So this turns out to be 0. So, in conclusion about complementary events, if you know that two events are complementary, you don't need to know the probability of an event occurring. It's automatically the case that their intersection is never going to happen, that one or the other happens with 100% chance, and that the chance of neither of them happening is impossible. All right, for the rest of the questions, I am going to give you some values. I'm going to say that, let me make this bigger. So for the next 3 problems, I want you to allow the probability of A to be 0.3 and the probability of B to be 0.4. Okay, so I'm going to put that at the top of each of these. And then you can pause the video and solve for each case these questions. Okay? So you can pause it now or after I write this, so if you have questions. Okay, so for each of these, answer the question. I'm going to show that one above just so you can contrast. So learning the difference is going to help you understand the concept. The next pair of events are known as disjoint. Disjoint means that they never overlap. Okay, there's no overlap. In other words, either event A happens or event B happens or something else. Now, going back to here, in this complementary case, we could say event A was either it rains or it doesn't rain. Those are the only two possibilities that I've laid out. It's either rains or it doesn't rain, right? That covers all the possibilities. Other things can happen, but that's not what I'm interested in. I'm interested in rain and the opposite of rain, no rain. And in the case of disjoint events, in A and B, in this instance, either A happens, B happens, or something else happens. And A and B cannot happen simultaneously. So not all events have this kind of property, right? So it's different. You can tell different stories around this. So we could say, and I have examples in the notes. What if A is the doctor? There's a doctor, and the doctor is in the hospital. That's event A. And event B is the doctor is in his office. And then not A or B, otherwise the area around here, the something else would be that either he's in the hospital, or he's in his office, or he's at home. Sorry. Okay, so he's either in the hospital, office, or the only other possibility is he's home, right? Again, you can tell a story with more complicated places to be, but let's say those just the way it is. Those are the only places he goes. He has staff that do all the shopping for him and everything else. So, what are the three probabilities? What's the probability of A and B, probability of A or B, and the probability of not A or B? In the first case, probability of A and B, do they ever overlap? No. So the chance of A and B both happening at the same time is 0. So in other words, this doctor is either in the hospital, in his office, but he can't be in both. These are distinct places. So you can't say there's some doctors who have their offices in the hospital. So that's not the case for this situation, right? So the way I've laid it out, the way I've shown you they're disjoint, it implies that he can't be in both at the same time. That's disjoint. Okay, what about probability of A or B? So A or B, what is that? That's where I want to know the chance that he's either in his office or in the hospital. So the chance that he's in the hospital is 30%. Sorry, it's jumping. The chance that he's in the hospital is 30%. The chance that he's at his office is 40%. So 30 and 40, well, how do I figure out the chance of being here or here? Well, since they're disjoint, I just add the probabilities. So that's just an intuitive sense you have to do that, I hope. That, you know, the chance of being in either A or B is going to be the probability of A plus the probability of B. So it works out to be 70%. You just add. Now the reason why, it's not more complicated than that is because that's all it is. It's either or. It's either this or that. I sum the probabilities, and that's one of the rules we're going to review. So a lot of what we're doing here will be, like I say, it's intuitive that you do that. In fact, it constitutes a rule in probability that you can do that. So finally, the not A or B. So in other words, what about this? What's the chance of that happening? Well, we know how to do that because the whole entire space is 100%. And I just need to subtract the chance of either the doctor being in the hospital or in his office. So I know how to do that. That's just going to be the probability, of not A or B is equal to 1 minus, right? The probability of A or B. And 1 minus 70% is 30%. Oh, I see you guys are answering my questions. I didn't notice that till now. Very good. Let's see what you have to say. I'm going to read some comments here. You guys have been answering. Very good. Very good, Isadora, you guys. Thank you. Okay, so maybe then, if you want to give it a shot, I'm going to ask you. So let me just recap this one, and then you guys can try the next one yourselves. I'll give you a moment, give you a couple minutes. All right, so when events are disjoint, they don't overlap, just like complementary events. So in that way, they're similar. However, the big difference is that there's this something else. And in this case, the probability of each of the events mattered for me to calculate the probability of A or B and not A or B. But in general, there's no chance by definition of them overlapping, so the probability of them happening together is 0. Okay, so that's the only one you don't need values for, but you do need values to calculate A or B and the outside space, which is 30%. So let's contrast these two one last time. And I'm going to say, and this is going to come up in your review of the material, complementary events are disjoint, but not the other way around. Okay, think about that. Complementary events are disjoint because the probability of A and B is equal to 0 for complementary and disjoint events. So they're the same that way. However, disjoint events don't have the properties of complementary events because they don't fill the whole space. And so it doesn't have these properties. You actually need to know the probability of an event to calculate all the other probabilities. All right? Okay, so why don't I give you 2 minutes to work on A and B overlapping. Okay, I'll give you 2 minutes to work on A and B overlapping. Remember, you can review this video and at your own leisure. So anyway, let me give you 2 minutes to try that. Okay, I'm back. All right, so give you a couple minutes to think about that. Now, these events are overlapping events, and that's what it looks like. There's a piece where they actually intersect, and that intersection piece has a name. The intersection piece is called probability of A and B. So the chance of A and B happening at the same time is something I want to calculate. I also want to calculate the probability of A or B. And then finally, I want to calculate the probability of not A or B. So you should feel like you're missing something, because you are missing something. You don't have the intersection piece. You don't know what that is. And some people would say, but all you have to do is multiply this and this. And I have to say to you, based on what? How do you know to multiply these two together? And what are you getting? In fact, it's not going to work here. We don't have enough information to know we can multiply these two. So it turns out that you cannot answer this question unless I give you extra information. Okay? So I have to give you something like this. And I'm going to say it's given. It has to be given, or you can't answer this question. Just knowing that two events overlaps doesn't tell you what this inside piece is. But now that I say it's 10%, now you can figure out some of the things. So you know this answer was given, A or B. Now how do we figure that out? A or B. A or B in this case, comparing it to the one above, A or B means either event A happens, or B happens, or both happen. Okay, so this could be the situation where the doctor is in the hospital and the doctor in the office, but maybe he can be in both. Some fraction of the time, maybe he has an office space right in the hospital. All right, so that's where those intersect. That's an example. And out here is still available as well, and that's what we would calculate. That's to calculate that would be known as not A or B. So how are we going to get A or B calculated? Well, I could use the rule I did above and add the two probabilities, but something is missing, or that's not exactly the answer. Okay, the precise way to do this would be adding A to B, but then that piece, that overlapping piece, has been added twice. So there's no real pretty way to do this. If I add A's chance to B's chance, this overlapping piece gets added twice. So simply, I have to account for it by taking it off once. So that's what I'm going to do. I'm going to minus the chance of A and B. Do that again. Okay, so that's going to be A's chance is 30, B's chance is 40, minus their overlap, which I was given. So it's 30 plus 40 is 70, minus 10 is 60. So the answer is 60% chance. And finally, we know for the chance that both don't happen, or neither happens, that's another way to interpret in a word problem. This would be neither in English. You want to take away one probability of A or B from 1, and that would be 40%. Very good. Okay, now the fun. Let the fun begin. The fun part. We've learned that complementary events are also disjoint. Disjoint events are not complementary because of this other thing that can happen, the not A or B. And we've learned the difference between disjoint and overlapping events. And now I feel like those are interpretable, those are easy to understand. And now's the challenging part. What are independent events? What is this where these look the same? A and B looks the same. There's an overlapping piece. I drew them a little bit different. They overlap a little differently, but I mean, what's the difference? The difference is when I tell you events are independent, I'm giving you information about their coincidence when they happen together. This can be computed by multiplication. Okay, so when your instinct to multiply 30 and 40% to calculate this overlapping piece is misguided unless you know that the two events are independent. So what does independence mean? Independence refers to the fact that just because one event occurs, it doesn't impact the chance that the other event occurs. Like the probability of the other event stays the same. So in other words, if events are independent, then the chance that the doctor goes to the hospital is 30%. The chance that he goes to his office is 40%. And if they're independent, if he's in the hospital already, there's still a 40% chance that he's going to be in his office, or that is what independence is. It doesn't affect the probability. Now, is that necessarily true? Not necessarily. Okay, so if it's a doctor who is more likely to go to his office in the hospital when he's in the hospital, the probability changes from just the 40% in general. Okay, that would be dependent then. Those would be dependent events. And you can't see it in a Venn diagram. Okay, you can't see independence in a Venn diagram. You can see disjointness, that's something different. Disjoint is when they don't overlap. But in fact, events are overlapping and independent. They both overlap. It's the degree to which they overlap that independence controls. Okay? Which is funny because I'm saying independence, but with the independence, you could calculate this probability here, because when you're in A, the chance of being in B stays the same, and that's why you multiply. So of the opportunities that you are in A, so let's say you're in A, the probability of also being in B, when I say the word of, this triggers me to multiply. Okay? Multiply por multiply. So let me see. Let's calculate each of these now. Probability A and B is equal to probability of A times probability of B. And I can do this because the chance of being in A, if I'm in A, of those times, there's a 40% chance that I'm also in B. So you multiply. In general, let me go back. Oops. Oh no. put that all back in. In general, let me show you. I can't just erase. It all disappears. Let me write in general what it should be. In general, put it down here. In general, to find the probability that an event A and B happens, it's equal to the probability of A, and of those times okay, so you're going to take the probability of A and multiply the probability of B given A happens. Okay? This is actually the rule. This means given, if you've never seen that before. So this is called a conditional probability. So when you calculate A and B, this is how you calculate it. You need to know if you're already in A, if A happens, you're already in A, what's the chance of B happening? If that doesn't change, just because you're in A, the probability of B doesn't change, that's why you end up multiplying. All right, because it doesn't matter if A happened or not, it's still, all I want is the probability of B. So let's go back to what I was doing. So we can calculate now the probability of A and B using the same numbers as above. A is 0.4. B is 0.3. Oh, sorry, it's 0.3. Did it backwards. Okay, so A is 0.3. Multiplied by 0.4 is actually 12%. 0.12. Okay, so it's 12%. Now that I know that, I can calculate the union of the two events, and then I can calculate the complement of the union. Those are the three things I'm interested in. So I can calculate the probability of A or B, which is going to be I'll give you the answer, and you guys can ask me questions about how I got it if it's not clear to you. A or B will be 0.3 plus 0.4 minus 0.12. 0.3 plus 0.4 is 0.7 minus 0.12 is 0.58, right? And so the P of not A or B is equal to 1 minus 0.58 or 0.42. And that is how I calculate everything. I believe I have an exercise, the same exercise in the Moodle page. So you can try it again and you can compare your answers. I call it Unit 4 Probability Overview. I have the same numbers and I have it laid out very nicely. So I'm going to ask you to write that out yourself, and then tomorrow we can discuss it some more. Okay? Try and get all these calculations yourself, and I will go from the first pages of the notes to as far as we get. And please have a look at the notes and also look at the videos that are on the Moodle page. And we'll see you tomorrow, unless you have some questions. Just gonna look if you have questions. No comments? It was a little hard to see, maybe. It's getting a little messy. Okay, guys, I'm going to say goodnight for now. Work on that, watch the videos, and we'll talk tomorrow. See you at 5. Bye.